Hi, my name is Anna Petrovicheva, and today I'm talking to Dmitry Petrov, who is the co-founder and CEO of California-based high-tech startup named Iterative.ai. They created DVC on data version control, which is one of the most popular tools to organize your machine learning research and production. DVC tracks your experiments, manages your data versioning, and helps you do the research in a very predictable and an organized way. This episode is sponsored by Intel. Near human level of perception in an embedded device is not a science fiction, it's a reality. OpenCV.AI Kit, or OG, uses Intel Myriad X chip for neural inference and depth perception, and this combination results in almost human level of understanding. OpenCV.AI Kit is supported by a strong toolchain, including Intel's OpenVINO toolkit. OpenVINO toolkit can help you develop applications and solutions that use deep learning, and also to deploy these solutions across a variety of hardware, starting from CPU and all the way to visual processing units. Use OpenVINO toolkit to augment your OpenCV projects that need a deep learning module. It's free. Download it and try it now. Dmitry, welcome to our podcast, OpenCV.AI for Entrepreneurs podcast. I'm really happy to have you here. So my first question to you would be about the tool that you develop, the great software that is called DVC, Data Version Control. So we share a common love for open source solutions, right? So I'm OpenCV developer, you develop DVC and other great open source tools. Could you please tell me what, in your opinion, is the power of open source, right? The main power that makes people develop open source solution compared to closed source solutions.
First of all, thank you for inviting to your great podcast. And yeah, let's talk about open source. Why open source? Why it's important? I think there are a few components why open source. I believe the biggest component of open source is community and user feedback. It's really great to work on open source because you have like a very quick feedback loop from users to the developers, and also you have like a variety of users, variety of clients. It's a huge difference between like having like 100 clients in the first like half a year instead of like having like 1-2 clients when you work in a regular kind of business environment using like regular sales strategies. I believe this is a big power, and there are a lot more components of open source. We can discuss this separately, but community is definitely the major one.
Okay, so compared to the comparing open source solution to closed source solution, in terms of reliability of the software, what do you think? So what software typically is the most reliable solution?
I think reliability is quite a separate question. So I don't see kind of a clear connection between open source and reliability. In open source, at least as open source works today, you still have a core team. You still have core contributors, and they manage the quality of software in a different way, right? They can prioritize reliability, they can prioritize like feature development, and this is the balance that those people are choosing. So I don't think it's a big difference between open source and closed source.
Got it. Thanks. Could you please tell us just a bit about DVC and why it's important and why it's open source?
Yes, DVC is data version control. It's a tool which was created to manage data, manage experiments. And a big component of DVC is a connection between data and code. This is why it's DVC. Like it controls data, which means all the data artifact that you use. It might be like gigabytes of text data. It might be like millions and hundreds of gigabytes of images and stuff like that. And And it helps you to keep track of all the code with data and versioned all these components during the experimentation phase. This is the major functionality of DVC.
How did you come up with the idea?
I was data scientist at Microsoft, and I've seen how engineering team work on ML project. In business environment, you have a lot of pressure, right, comparing to academia, and this pressure pushed teams to use kind of best practices. And what I realized, best practices on ML projects, on data projects, are very different from software engineering projects. And Microsoft built like AI tools specifically for this. And I was thinking, all right, Microsoft has the tools, kind of AI platform, and some large companies also have internal AI platforms. But how about the rest of the world? How those AI platforms should look like in the future? And when I start thinking about this, I come up with kind of idea, not idea, it's like straightforward, that those solutions needs to be like open source eventually. They need to be open, they need to use kind of some common sense set of conventions. And when I start thinking about this, the tools, I come up with the idea that any tools needs to have a versioning component, data management component, data versioning component under the hood, and this is how DVC was created.
Got it. That's interesting path to creating an open source tool coming from an industrial and closed source background, right?
Yeah.
So could you please tell me how was DVC growing in terms of the community, in terms of open source community, right? So there is a core team that develops the main tool, but I'm sure that there are a lot of people all around the world that bring in the functionality to DVC. How would you, what do you think is the percentage, the ratio between the new functionality created by the core team right now compared to the functionality that is created by people all around the world?
In the sense, DVC, it's more or less the same as any open source projects today. About 90% of the functionality, I would say 90-95% of the functionality is created by core team. And this is, it looks like it's kind of a common pattern, common trend. Core team develop like the majority of source code, the majority of the functionality. And yeah, this is how it works today. So people contribute to code. We have like a lot of contributors. Each month we have like around 10 new contributors who bring some code to the tool. But usually there are small fixes, sometimes they're kind of improvements, but still the majority of the work goes to core team shoulders.
Got it, thanks. So what do you think is the ideal collaboration between open source software and business? Because eventually any business has to make money, right? And what do you think is the best way to collaborate between doing something for free for open source for everybody and making money on that?
So are you talking about monetization, right, of open source specifically, or some other components? Or your question is wider?
So I think it's a bit wider. So what do you think is the best way to do that compared to how it is done now, and how it is done now, obviously?
Yeah, so this is a good question. If you're talking like, if you're asking like how it should be, I don't know how it should be. What do we need at the end of the day? We need people who work on a daily basis on some open source, right? This is what we need. If you don't have those people, it's really, really hard to maintain like a substantial piece of software, right? And we are talking about kind of the system that will be like part of some industrial solutions, some industrial teams, right? So you need to have those core contributors, and they need to be paid somehow, right? And today, what kind of industry come up with with the idea that developers build like kind of two pieces of the project. One piece is open source when everyone is using, everyone can use and take it and use it. And second is more enterprise specific. General rules here. General rules is if some functionality is needed for an individual, if some functionality is needed for like team of 3, 5, it should go for free. If something is needed for a company, kind of for complexity around the company structure, then it's about enterprises, and it's fine to provide additional services or additional software specifically for companies, for enterprises. And this is when you when open source teams charge enterprises. Yeah, it's about kind of complexity of the problem you are solving and complexity of kind of organizational complexity. This is a usual separation, and in most of the cases, all the security features, all the kind of management features goes to the enterprise part, and the rest stays for like everyone.
So specifically for DVC, if we speak about the enterprise clients, these are big companies, right? These are big companies that require complex data management system, experiment management systems, right?
Yes, we do have large clients, and our focus, of course, like large clients, right? Eventually, but actually, we have like relatively small, mid-sized clients. So it's not necessarily like enterprise, like thousands of people and like many teams of data scientists. In some cases, it's a relatively small company, maybe like 100, 200 people with one team of data scientists. They still need something. They still need like automation around them all.
Yeah, it seems that more and more people and companies right now understand the importance of MLOps, right? The importance of managing data, managing the experiments in a very reliable way. So, what do you think is the main power of having these reproducible processes in AI and machine learning model development? Why it's important?
It's important for a variety of reasons. One of the reasons is you need like a reliable process, right? Reliable processes around your applications. It's especially important when machine learning, when AI component serves some online applications, right? You need kind of a clear discipline around like around your ML models and datasets and stuff like that, right? What we should do if something fails, how we can revert to our previous version of the model, how we can retrain on the new data set without like asking data scientists and spend another like 2 weeks of doing this. This kind of question that people need to answer. And second component is a kind of a knowledge sharing, because in software engineering as well as in machine learning, you need to have kind of some tool when people can understand ideas of others, right? And this component is also important. It helps a lot in the long run. The first part is kind of about like reliability, right? About like what is happening today, how to solve some productionization issues, and the second is about like knowledge sharing and long-term effect.
Mm-hmm. Thank you. My next question is going to be about the comparison, how academia compares to industry in terms of these processes of model development. What do you think is the main difference between them, and where are they similar?
Yeah, so I worked at academia more than 10 years ago now, and then I moved to Microsoft, and I have seen how ML teams in large companies in industry working on ML models. And the difference is, I think the biggest difference is like how much pressure you have from the business in terms of like timeline of development of your models first, and second is operationalization of your models. Mm-hmm. And in the industry, the pressure is much bigger than in academia, right? Because you have like a tighter timelines to deliver some result first, and second, you need to have some process around your result. You're kind of responsible for this result, and you should be able to answer like kind of productization questions. And this force the industry use all the best practices. In academia, priorities are very different. Priorities kind of like innovation, right? Like new ideas, sharing ideas, and this like pressure from timeline point of view, appearance point of view, it's not like they're not so significant. In this way, what I have seen, if academia is not very motivated to use those best practices. For academia, it's kind of like nice to have reproducible result, reproducible paper, but it's not something that team will be wasting time on. And in fact, it takes a lot of time to make those results reproducible and especially like operationalizable, right? When you can use it in a real environment. It increases development cost sometimes like 5 times, sometimes 10 times. It's not the price that academia is ready to pay, to my mind.
Got it, thanks. So the recent trend that I saw in academia, maybe in 2-3 last years. So maybe from 2014 all the way to maybe 2017, everything was kind of exponential, right? Everything was growing so fast, and there were these like incredible numbers about CDPR being fully booked in like several seconds, right? And then right now I see that artificial intelligence is kind of the new normal, right? So there is no exponential growth as far as I see anymore. And everything is kind of slowly becoming the new normal, and becoming the processes are becoming more stable and more mature in the industry. Do you have the same view as I do, right? And if yes, what do you think it says about MLOps and the development of the industry in general?
Well, I think part of this is just a kind of a fashion, right? So this is why like people are very eager to join some conferences, to participate in the conferences. Today, yeah, definitely like we have like a bit less kind of fashion component in this, and it's a good in some sense. But I still see that this topic is the hottest one in academia, and this is the hottest one in the industry. Last year, it's maybe just not as crazy as it was in the previous year. Yeah, it might be like part of the fashion. It might be partially because everyone is busy by COVID and all other stuff. I don't know what is the global trend, but yes, today we have today interest kind of changed during the last year.
Do you think that the field becomes more mature in terms of the processes everybody applies?
Yeah, so I can say that I just recently said, like 1 minute ago, I said that academia is not ready to pay with this like high price for appearance, right, and reproducibility. But in fact, they're interested in this topic. They're very interested in, and they understand like without this, academia won't survive in the long run, right? They're doing a lot of work actually in this sense. And I had a few discussions with people who organize large conferences, including like NeuroNIPS, and they're trying to kind of be in the world when every paper is not just like not just represent ideas, right? But they represent code and data sets, and everyone can try and make sure that this is actually works. Not only in like a very specific like environment with very specific like settings, but it works in kind of more reliable way.
Yeah.
So academia is very interested in this subject. My general feeling is it will take time. It will take probably another like 5, 10, 15 years to get there.
So it's a slow process, right?
Yes. In academia, as I said, pressure is not as big as in the industry, and this is why this process is kind of spread around many years.
Got it. So what do you think about the general future of artificial intelligence, machine learning, say for the next 10 years? What do you think will be the next biggest thing there?
Oh, well, it's a good question. I think the biggest component should be and will be, this is what I already see, is kind of maturity of this area. We are going to be kind of more rigorous about the results, about this new ideas and knowledge, and we should have a better kind of tools and practices on how to get to the result, how to evaluate the result, how to reuse the result. My big belief is we need to learn how to reuse result of others in a very easy way. And this is why I can bring the industry to the next level. Not the industry, not only the industry, but science as well. Because today we share only ideas, and from idea to kind of actual system, you need to waste another sometimes a week, but usually a month, to reproduce some ideas, to make sure those ideas from a paper actually works in your settings. And let's imagine you can do this in 1 hour, 1 day, right? It will change dynamic a lot, and I believe this is the next level. Instead of sharing ideas, we should share kind of more meaningful results, which you can check quickly, try quickly, and build more complex solutions on top of those results. So just idea, I think it's not enough. We need to make to the next level.
Cool. Yeah, thank you. So my last question is going to be about the skills. So what skills do you think will be needed in the next, say, 10 years to develop solutions in artificial intelligence, machine learning, or open source solutions?
Yep. Yeah, so skills is very interesting. First of all, I believe for people who work on machine learning for artificial intelligence tools, mindset is a little bit different, right? And we need more people with this kind of a new mindset. I mean, not new mindset, but at least a little bit different mindset, when people think more in kind of a quantitative way, not a structured way. And I see this as a huge difference between people, between some different kind of professionals. I think this is very important from one side. From another side, those people need to learn best practices in the tools, or at least come up with some set of tools from engineering. First of all, software engineering, right? Because this is the closest area. And from engineering in general, they need to come up with kind of a framework, workflow, more predictable workflow. Predictability, it's an important part in this process, because you already have tons of risk in AI projects, right? And if we can reduce these projects, if you can reduce the risks, then it becomes way more interesting for business, right?
Yeah, that's for sure. Thank you so much. It was a very, very interesting discussion. And I hope that in maybe 1 year or so, we will have this discussion again and see what happened in the industry during this year, right?
Yeah, it would be great to have another discussion, and see the progress.
See you then, and good luck with the tool that you are developing. Thank you.
Yeah, thank you for inviting. Yeah.
Like our guests on the show, I don't just enjoy talking about computer vision and artificial intelligence, they are also what I do for the living. At OpenCV.AI, where I work as the CTO, we help our clients create incredible new projects and deliver them into real life, using our decades of experience in computer vision and related fields. Of course, it's not just me. For example, Dr. Gary Bratsky and Dr. Satya Malik are part of our team. But it isn't all just fun and games. For example, we created a number of medical solutions that help save human lives. OpenCV.AI is already helping our clients from all over the world bring spatial AI and edge AI into our everyday lives, thus making the world a smarter and safer place. You can learn more and contact us at OpenCV.AI.